Hi everyone, it's Coach Fred, and so today we're going to be talking more about polynomials and really about polynomials written as linear factors. So not in standard form, but in what I like to call factored form or intercept form. So let's look at a polynomial in standard form. Let's look at a polynomial expression, x cubed minus 2x squared minus 15x. Okay, so I'll make it a function actually. So we've got this polynomial in standard form. We can see that it's a degree 3 polynomial. So we've learned some things about what that graph is doing, right? We can say that the leading coefficient is positive, the degree is odd. So we know that the end behavior of the graph is going to be down up, right? So it's going to look something like that. But we really want to know what's happening in the middle. And to do that, we need to find our x-intercepts, our y-intercepts. And so an easy way to do that is if this function is in factored form or in intercept form. Now, the important thing to know is right now I'm providing you with a polynomial that is factorable. They're not all factorable, and we're going to be learning a new technique to do that. All right, but we can factor this one first by taking out a GCF. Recognizing I have a trinomial that's a quadratic, and I can factor that further. So let me come up here. X minus 5x plus 3. Remember, we're looking for the factors of 15 that add to negative 2. Okay, so now I have this in factored form. So what does this do? Well, it tells me more about my graph. It tells me where my x-intercepts are. So as a reminder, if we want to find the zeros of a function, we call them solutions of the function or of the polynomial. And sometimes, yes, sometimes they're going to represent x-intercepts. Now, how is it that we find the zeros? Well, to find the zeros, we set y equal to 0 and solve the polynomial. Now, we used to say with quadratics that we solved by factoring, okay? And we then apply the zero product property. So let's see, set each factor equal to 0. So applying the ZPP. Okay. All right, so in this case, we can see that our zeros would be 0, 0, 0, 5, 0, and negative 3, 0. So that does now tell me more about my graph. So if I were to plot those, I could kind of see what's happening in between. All right, if it is not an intercept form, then the best way to do it is to put it in intercept form. So first you're going to try to factor it. And then we're going to, if it's not factorable and it's not quadratic, we're going to look at two new methods. Now remember, factoring is breaking up something into multiplication. So if I actually have one of the factors of the polynomial, I can find the other by dividing. So our new methods involve division. One of them is long division, and one of them we call synthetic division. But those we're going to save for another day, okay? I just want you to hear the terms. All right, so let's go through everything we can now. Here I've given you a polynomial in factored form, in intercept form. So we want to find the zeros and state the degree of the polynomial. Okay, so remember we talked about this. To find the degree, if we were to multiply this all out, we'd be multiplying all these powers here that we have. So if you look at each factor and raise it to its exponent, this would be, and add them, it would be a degree 3 polynomial. To find the zeros, we'd use the zero product property, set each of the factors equal to 0. We can see them clearly. So we have x equals 0, x equals negative 3, x equals 1. We could write those as points, 0, 0, negative 3, 0, and 1, 0. Okay, we can determine the end behavior of the graph in this case. So because we have an odd degree, leading coefficient, and it's positive, right? We saw that it was positive. We know that our end behavior is going to be down up. So let's plot those. So we have, so we can see it a little bit better. We have 0, 0, we have -3, 0, and we have 1, 0. Okay, and we know we have down, up. All right, I also would want to find my y-intercept, because we always want to do that if we can. So to find our y-intercept, we set x equal to 0. So we would get 0 times 3 times -1. 0 times anything is going to give me 0. So my y-intercept is 0, 0. We kind of see it there too, don't we? Because that's our y-intercept. But I guess the point now is, like, I certainly know I have something going like this, turning around, going like that. But what, could I find points here and here? Well, I certainly could, okay? So how would I do that? So let me go back. Let me plot those again. I could just make a little table and find out what's happening, say, between -3 and -1, okay? All right, so let's do that. I'm gonna try, -3 and 0. I'm gonna try -2. So if I plug -2 into my function up here, I'm gonna get -2 times 1 times -3, which gives me 6. So now I have a point -2, 6 on my graph. So I can see it's going up that far. Could it go up farther? It sure could, but this again is a sketch. I'm also going to try -1. If I do that, I'm going to get -1 times 2 times -2, which gives me 4. So I can really, if I want to, use what I know about inputs and outputs and functions to find other points on the graph. Do you have to every time? No, certainly not. These are sketches. We really want to just kind of see what's happening, but could you? Yes. Could I find a point in between here? Sure, I could plug in, I don't know, 1/2 if I wanted to. But I think this is enough for now, so I'm going to draw my graph. I'm going up because I'm down to start. I'm going to turn around here, come down here, and then I know I need to go back up. And so there I have my polynomial. Sorry, remember, no sharp curves. And there we go. All right. Now, we also talked in class last week during your thinking routine about what happens when a factor is raised to a different exponent. And this is called the multiplicity. And that degree actually tells us what's happening at the graph, okay? So multiplicity in factored form is the degree the factor is raised to. Again, and it tells me what occurs at the x-intercepts. All right, so what determines how many x-intercept the graph of a polynomial has? The number of factors it has. So for example, if I give you y equals x plus 1 squared, x plus 5 cubed, it has one x factor. It actually has two x plus 1 factors, and it has 3 x plus 5 factors. So I know that this is telling me its degree is 6, which means that it could have as many as 6 x-intercepts. But the multiplicity tells me how many are actually the same, okay? So what determines the graph's behavior at each x-intercept? That would be its multiplicity. So let's talk about this. If it has a multiplicity of 1, you can see each of these factors has a multiplicity of 1. So if I were to graph it, I know I have an x-intercept of 0 and -1 right here, right? And I can actually tell this is quadratic. So this graph is going to look something like this. So at that x-intercept, that degree 1 multiplicity actually means that the graph is just going to slide right through those points. Whereas in this next one, I can see that I have a degree 1 multiplicity and a degree 2. That tells me what's happening at each of their x-intercepts. Now, we did talk about this, but it should kind of make sense to you that this is a quadratic. So quadratics turn around. And so at that x-intercept, we're going to have what we call a bounce. So here again, I have -1 as an x-intercept. I have 1, 2, 3 as an x-intercept. So that multiplicity of 1, this was a degree 3 polynomial, and positive, so it's going to be going down up. So I have something that looks like that. I'm turning around because I got to get back to the -3. But what's going to happen there, instead of going through it, it's going to bounce and go back up. Because remember, we needed down up. Okay? All right, and then the last multiplicity we can have is a multiplicity of 3. And this one, you can see it here, it looks like a cubic. And remember, the cubic graph looks like that, right? The quadratic graph looks like that, and the linear graph looks like that. So those are the multiplicities. That's what's telling me what's happening at that point. So I like to call this a squiggle through that x-intercept. So here we go. We have a degree 4 polynomial. It's positive, so I know that my end behavior is up, up. So I have an x-intercept at -2 and an x-intercept at 3. So I know I'm going up, up. It's going to go right through -2, but as it comes around and turns, it's going to squiggle through 3. And that's because that x-intercept has a multiplicity of 3, okay? All right, so let's try this, okay? And actually, I'm going to change this a little bit. I'm going to make this x plus 2 squared, and x minus 3 cubed, okay? So let's change that. All right, so we have our x-intercepts. So we have 0, 0. We have -2, 0. And we have 3, 0. There's my x-intercepts. My y-intercept is also 0, 0. I can see that, okay? My degree is 6, and my leading coefficient is positive. So I know that my end behavior is up, up. Something like that, right? Up, up. Okay, so now at these x-intercepts, I'm going to list my multiplicity. So at 0, 0, I have a multiplicity of 1. At -2, 0, I have a multiplicity of 2. And at 3, 0, I have a multiplicity of 3. So at 1, it's going to go through. At 2, it's going to bounce. And 3, it's going to squiggle. Okay, so let's try it. So we know we're going to have up, up. We know I'm going to plot my 0, 0, -2, 0, and 3, 0. I know I'm going up, up. Okay, at -2, I'm going to bounce. Bounce. At 0, 0, I'm going to turn around somewhere, and I'm going to go through. And then at 3, I'm going to squiggle through. And there's my graph. Now, I certainly could then find what's happening here and here by plotting some extra points, okay? All right, guys, so that was a quick review of behavior at the x-intercepts and multiplicity, and how to factor to put a polynomial into intercept form. Have a great day.